Hi guys, welcome back. So today what we're going to be looking at is sketching parabolas in turning point form. If you haven't had a look at the previous videos on sketching parabolas, I would suggest going back and having a look, especially at that transformation video, because the stuff that we're going to do in this video is very similar, or very reliant, I guess I should say, on that previous video. So today, our learning goal is exactly the same as the previous learning goal, but success criteria is a little bit different. So we're graphing nonlinear equations using the turning point method. So I've got a few more words in the vocabulary this time because last time we only looked at a couple and we didn't actually go through and define translation, dilation, rotation, and we didn't actually go through and define turning point. So I want you to go back and do that in your vocab list. So let's have a look. So this is straight from the textbook chapter. So this is chapter 9.4. So how do we sketch parabolas in turning point form? Thankfully, this is actually something that you are familiar with. So this equation here is actually the exact same equation as the one that we looked at. So y is equal to a x minus c squared plus d. So all they've done is they've replaced the c and the d with a h and a k. So they've written it as y is equal to a x minus h squared plus k. So when it's in this particular form, and you might have picked this up from the last video, then magically I have something, so this has been shifted and it's been shifted to the right because it's x minus h, so that's been shifted right h units. And then this has been shifted up k units. So the new turning point is going to be hk. So that's why we try to get things into this turning point form. And the best way to get things into turning point form is by doing my favorite thing ever, which is completing the square. Okay, so if you have not done that, maybe actually I should make another video on completing the square. I do really enjoy it and I do find it really useful. Okay, so let's go through then. Let's have a go and jump straight into some questions. So these are on page 355. So for each of the following equations, state the coordinates of the turning point of the graph and whether it's a maximum or a minimum. So when I'm talking about a maximum or a minimum, if I was to draw my two parabolas, if I have a smiley face parabola, then the turning point is going to be the lowest part, or a minimum point for that parabola. If it's a sad face parabola, then it's going to be a maximum because that's as high as that value is going to go, is going to be at that turning point. Okay, so for the first one, all I'm going to do, so it's been shifted by 1 unit and it's x minus 1, so it's been shifted to the right one. So that means my turning point is going to be at 1 and then 2. So that's it for the first one. Now, if I have a look at this coefficient of a at the front, it's just positive 1. We don't bother writing positive 1. And so it must be a happy face parabola. And compared to the original function x squared, it's going to actually have the same width as the function x squared. It's just been moved across by 1 and up 2. Okay, so if we have a look at question B now, so again, the coefficient is just going to be 1, so it's not wider or narrower. So it's a positive, so that means it's a happy face parabola, so it's going to have a minimum turning point. And that turning point, well, this is x plus 2 now, so that's been shifted to the left by 2, and then it's been shifted down 1. Let's do a trickier one. I always like the tricky ones. None of these have a coefficient out there. Oh, this one does. Let's have a look at this one here. So question D. So this is now a negative value, so that means it's been flipped. So it's a sad face parabola. So that's going to be a maximum turning point because that's the max point that's ever going to go to is going to be this turning point here. And if I have a look at the coordinates, it's been shifted by 2 to the right. So that's going to be 2. And then it's been shifted up 3. So we can go ahead and we can check this using Desmos if you so desire to do. But I'm just going to leave it at that because I'm been practicing. All right, so let's go through and let's have a look at question 2 now. So this is on the same page. I think it was page 355 or 356. So state the coordinates of the turning point, whether the graph has a maximum or a minimum, and whether the graph is wider, narrower, or the same as that of y is equal to x squared. Okay, so let's have a look at this first one here. And again, lots of practice. Practice makes permanent. Practice the right things. I can see that this value at the front here is 2. Because it's a big number, that means it's getting steeper, so it's looking skinnier. And then it's been, it's positive 2, so it's a happy face parabola. Now this is x plus 3, so since it's x plus 3, it's been shifted to the left, so the turning point is going to be at negative 3, and then this has been shifted down 5, so negative 3, 5. Ooh, I like the tricky ones. I want to do a tricky one. I think this is the trickiest one they got here for F. Okay, so 0.2, so I know that this is a value between 0 and 1, or a fraction or a decimal, so it's going to make it flatter. I also know since it's a positive value, it's going to be a happy parabola. It's been shifted to the right by 1/5 units, or 0.2 units, and it's been shifted down -0.5. So I guess you can kind of start to see now why I had that x minus c in the last video, and why or how that impacts on the turning point. So basically, all you need to do to find the turning point is you just need to flip this into whatever the other value is. So if this is a negative, it's going to change into a positive. If it's a positive, it's going to change into a negative. And then this one here just stays as it is. And then we use the happy or the sad positive or negative value out the front to tell us whether that's going to be facing upwards or flipped downwards. All right, so let's have a look. Oh, did I answer all that question? Coordinates of the turning point, check. Minimum or maximum, check. Because we know that if it's a happy, it's going to have a minimum. That one's a happy, so it's going to have a minimum. And if it was a sad, it would have a maximum. And whether it's wider, yeah. So I think we've gone through, and I think we've answered all those questions. Okay, so select the equation that best suits each of the following graphs. So all I'm going to do is I'm going to have a look at this turning point here. So this turning point is at 2, 3. Now, because it's been shifted to the right by 2, that means it's going to be x minus 2 squared, and then it's been shifted up 3. Now, I don't know what this value a is out the front here, but if I was given some other coordinate or some other point, I could probably determine what that was going to be. So do I have one on here that's similar to that? Oh, sorry, and also it's a sad parabola, so it's going to be some negative value. And the one that looks closest, I think, is going to be B. So let's write B for this graph here. Okay, I'm going to go ahead and I'm going to do this second one now. So this time the turning point is at, well, the x coordinate hasn't changed. That's still at 0, and the y coordinate's been shifted up 1. So if I was to write this, it would be, well, it wouldn't be x plus or minus anything. It would just be x squared, okay, because x plus 0 is just x, and then it's been shifted up 1. And I also know that this has been flipped. It's a sad parabola, so it's going to have a negative value. So which one would look the most similar to negative x squared plus 1? That would be, oh, this one here, so E. So let's write E here. I'm going to do one more example for you, and I think, as always, I'm going to pick a nice, let's pick a tricky one. We love the tricky ones. Oh, I think I'm going to go with this one here. The last ones always tend to be a little bit trickier. I do like that. So that is now being shifted to the right by 1 and down 3. So, and it's also a positive parabola. So that means that this value A at the front here is going to be positive. Since it's been shifted to the right, it's going to be x minus 1 squared, and then it's been shifted down 3, so that's going to be minus 3 units there. So which one is most similar to that? X minus 1. Oh, this one here looks pretty good. So I'm going to say that one there is going to be A. Okay, let's move on, shall we? So question 5, determine the x and y intercepts where they exist for the parabolas with the following equations. Now we've seen this before when we've worked these out algebraically. If we have something that looks like this, it's being translated up and away from the x-axis, so it's never actually going to pass through that x-axis. Now the only time it won't go through the y-axis is if it's actually being turned sideways. And we're not dealing with these sorts of functions just yet. This is actually in the form x is equal to y squared. So it's actually transformed that by flipping that sideways. But we're not dealing with those kinds of problems. We're only dealing with y is equal to x squared type problems, so we don't have to worry about that. So let's have a think about what's going on with each of these. Now, to find the turning point, I'm just going to flip whatever is in the brackets to the negative version of itself. So it's at -1 and -4. So if I was to draw this, this is also a positive happy parabola. So this is going to go through at -1, -4. So turning point, something like roughly like this. Now this is going to have 2 points where it crosses the x-axis. So we will be able to find the x-intercepts for this one. So just as a refresh, when we're looking for the y-intercept, we're going to let x equal to 0. So y is going to be equal to 0 plus 1 squared minus 4. 1 squared is 1. 1 minus 4 is going to be negative 3. So this y-intercept here is going to be at negative 3. That seems reasonable to me because the turning point is down here at negative 4. All right, so let's find the x-intercept. So the x-intercept is when y is equal to 0. So 0 is equal to x plus 1 squared minus 4. I'm going to take the 4 over the other side. And then the next step I'm going to do is open up those brackets by taking the square root. Now, when I take the square root, it could be the positive or negative square root of this because positive 2 squared is 4 and negative 2 squared is also 4. So I'm not sure which one it is. So I'll put both. And that's going to be equal to x plus 1. Then I'm going to subtract 1 from both sides. I might just finish off this working over here. So the first one is going to be positive 2 take 1 is equal to x. So that will be x equals 1. And then the other one will be negative 2, because this is the negative version of this answer now, minus 1, is going to be equal to x. So that is going to be equal to negative 3. So we can see here this is going through at 1 and then here at negative 3. All right, I want to pick a tricky one that's not going to have a solution. So let me have a look. I think if we do this one here, I think this one here is not going to have a solution. So I'm gonna show you that one. All right, so first things first, just to start off here, because this does not have like x plus or minus a value, that means that it's not being horizontally translated. So it's only had this dilation and this vertical translation. So this graph here, I might give myself a bit more space, of y is equal to 2x squared plus 4. Let's write that formula. So y is equal, losing my voice, sorry, 2x squared plus 4. Don't worry, it's not Miss Rona. She hasn't found me yet. So this turning point is going to be at 0 and 4, and it's going to be dilated, so it's going to be a lot narrower and steeper, and so that's going to look something like that. So you can see here, this is not going to have any x-intercepts. So I'm going to prove that algebraically as well. So first things first, let's do our y-intercept. So our y-intercept is when x is equal to 0. So y is going to be equal to 2 lots of 0 squared plus 4. That's just going to be 0. So y is equal to 4. So that's going to be our point at 0, 4. And we kind of can see that here because it's going through the turning point. And the reason it goes through the turning point is because we haven't shifted it left or right. Okay, so now we're going to try to solve using the x-intercepts, and I'm looking for real solutions. I'm not looking for imaginary solutions. I'll talk a little bit about that. So x-intercept is when y is equal to 0. So that means I have 0 is equal to 2x squared plus 4. So if I rearrange, negative 4 is equal to 2x squared. Negative 2 is equal to x squared. So x is going to be equal to the positive or negative square root of negative 2. Now, we do not have a real solution for this, okay? Now, we haven't really spoken much about imaginary numbers. I might do an Algebra Basics video on imaginary numbers, but for those in the know, I could write this as x is equal to positive or negative 2i, okay? Because this is an, root 2i, because this is an imaginary number, okay? And it's imaginary because the square root of negative numbers do not exist. All right, so does not have a solution in the real axis, okay? If we were to draw this on the imaginary axis, absolutely it would. Okay, do we have another tricky one? I think that's basically all of them, because the rest of these, they have these negative values, which is going to drag this here, and that's going to have some solutions going through the x-axis. I do like it when they have tricky solutions, so I might just leave those ones because the rest of those are pretty straightforward. All right, so let's have a go at this next question here. And this next question is using my favorite thing ever, which is completing the square. Okay, so if you do not remember how to complete the square, I should make another video on this. So if I do end up making this by the time this video goes up, then you'll be able to jump over to that Algebra Basics playlist and you'll be able to see it there. So let's do 2x squared minus 3x minus 8 is equal to 0. To complete the square, first of all, I'm going to make sure the coefficient at the front here is equal to 1. So I'm going to have x squared minus 3 over 2x minus 4 is equal to 0. Now, what I'm going to do, I'm just going to ignore this negative 4 for the moment. Half it, square it. So this is going to become x minus 3 over 4, because I've halved it. Now I've got to square it. And I still have this negative 4 on the outside here. Now, in order to complete this square, I would have had to add 3/4 squared. So I'm going to add 3/4 squared on the other side to keep it balanced. So now I have x minus 3 over 4 squared is equal to 4 plus, because I've added that to that side, 4 plus 9 over 16. So that's just going to be 4 9/16. So last thing I can do is I can rearrange that now. So I have x minus 3 over 4 squared minus 4 and 9 over 16 is equal to 0. So this would be if we were trying to find the x-intercepts, for example, because we're letting y equal to 0. So if I wanted to write this generally as a function, I could just pop the y back in and write y is equal to x minus 3/4 squared minus 4 and 9/16. Hold on a minute. Now that I've done this completing the square, what do we notice? Wow, it's in turning point form. So that's why completing the square is really, really useful. I know I've harped on about this in class about 6,000 times, but it really is something, a skill that you can take forward into the future. So that's why I love completing the square. Also, when you start to do circle functions and stuff, or when you start to do conic functions in grade 11 and grade 12, you really need to be able to have that skill of completing the square so that you can actually find those functions. So please, 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 if you do not understand how to complete the square, I'll pop up that video, go back, watch that video, and then, you know, rehearse yourself, okay? I really think it's an important skill. I can't hop on about that enough. Okay, question 8. Okay, so question 8 is all about finding the equation of a quadratic that has a turning point of -4, 6 and has an x-intercept at -1, 0, and then state the other x-intercept, if any. All right, so I might just pop this, or I'll just leave that rest of that stuff on screen. I'll just pop this here because this won't take me long. So if it's got a turning point, remember the turning point form is y is equal to a x minus h squared plus k, and the turning point of this form is going to be at hk, so we're flipping this to the positive here, and then that's just the same. So here we can see the turning point is -4, 6, so this must be equal to y is equal to a, still don't know what the value of a is, x plus 4, because if I substitute in -4, then negative and negative makes +4, okay, so it changes, plus 6. All right, so now we've got to work out this value of a. Very kindly, they've given us a coordinate. So if I substitute in that coordinate, 0 is equal to a times by -1 plus 4 squared plus 6. So -1 plus 4 is 3. 3 squared is 9. So 0 is equal to 9a plus 6. So if I rearrange this equation now, -6 divided by 9 will be equal to a, and that's the same thing as saying -2/3. So this is going to be a parabola that's flipped. So I can now substitute that into that value there, and I can write this as y is equal to -2/3 x plus 4 squared plus 6. State the other x-intercept, if any. Okay, so the x-intercept is when y is equal to 0. So I might just clear the screen and I'll come back and show you that. All right, so the other x-intercept is when y is equal to 0. So that means 0 is going to be equal to -2/3 x plus 4 squared plus 6. Moving that over to that side, so -6 is equal to -2/3 x plus 4. Some people I think are thinking, oh no, what are we going to do? It's a negative number. But it's okay because we're going to divide through by this coefficient out the front. So when we divide through by a negative, that's going to change that back to positive. Lucky us. So 6 divided by -2/3 is the same as saying 6 times by 3/2. So that's going to make 9. And that's going to be equal to x plus 4 squared. Okay, so now that we've got that information, we can take the square root of both sides. And again, this could be the positive or the negative version, and that's going to be equal to x plus 4. So to find the first solution, we're going to do positive 3 minus 4, because if I took this over to the other side, it'd be minus 4. And so that's going to be equal to negative 1. I think that was the original solution that they gave us. And then the other root or the other intercept or the other solution of that equation is going to be negative 3 minus 4. So that's going to be equal to negative 7. So we're going to have two solutions or two roots for this particular equation. Alrighty guys, if you could not tell, I really do like this particular branch of mathematics. I'm going to leave it there. I might go film a video about completing the square, and I'll see you guys soon. See you.